So that graph it's going in the right direction, but look at this, guys. It's going to follow more like this. Now, I'm doing all that talking and not bound it. It's bounded by 4. And you vertically shift it up 4. Mr. Park.
Yes.
Do me a favor.
Mm-hmm.
Michael, can you recall what the original function was altogether that we finally went through all those transformations and we got that green graph to be the final graph? What was its name?
-2 to the power of 3 minus x plus 4.
Plus 4, okay. Park,
Yeah.
would you please, here we go, find f at 100
Mm-hmm.
for me for this function. All right, here's one, replace x by 100, he's going to do all this work. Find f at 100, way out there.
F of x equals
There was a negative sign out front.
1 minus x.
Yeah, then 2 raised to the 3 minus x. There was a plus 4 on the end. I gotta confirm something.
Okay, 4.
Was it exactly 4?
Yeah.
Okay, so I see it's getting close to 4. I don't think it's going to intersect it. Was it just close to 4?
I think it's too small, so the calculator's.
Oh, whoa. Maybe we should try a larger number? Like f of 1,000?
It's gonna be 4. Because it's a negative exponent.
Yeah, there's my function. Mr. Berkeley.
It's 3 minus x.
Yeah, 3 subtract x for your exponent.
Yeah. The calculator is saying 4.
4, even for 1,000.
Yeah.
10,000.
It's 4, yeah.
So it's, guys, it should be approaching 4. It's going to never get there. It's going to get awfully close to 4. That 4 is going to be acting as a horizontal asymptote. So while that device that you're using there gives it exactly as 4, right?
Yeah.
Not 3.99999?
No.
That's what I wanted. Okay, it should be close to 4. So guys, this thing does follow that red horizontal asymptote that should have been shifted up, like she's talking, up 4. So it made it curve and follow that horizontal asymptote. Okay guys, on this, we're good? Now, I mentioned the word, I think I erased it here, I think it was what, logarithm? L-O-G? Now, the next lesson, here goes. To try to get more of this chapter 4 done, let's make a connection here. I'm glad we caught this before I move further. Okay, here we go, guys. Part 1, this is starting over. I'm going to do this. I'm going to write down a few expressions for you. That's what this blue marker will work. And we'll start out with find the value. This is going to set us up for more of that work on that on those handouts. Guys, the first one looks like this: 2 raised to the 0. Next one looks like this: 5 raised to the 3rd. Next one looks like this: 32 raised to the 1/5. 464 raised to the, here guys, take 2/3. 5, let's try maybe 16 raised to a negative 1/2. I'm just trying to make sure I maybe mix some numbers here. Number 6 is off the top of my head. Let's see what else we can think of here. That might be enough. Let's place a negative sign. I think that might be enough. Let's try one more. 8 raised to maybe 4/3. and I are going to just tell the answer, the value for those strings of expressions. Guys, no problem on the first one. 2 raised to the 0 definitely is 1. Any expression raised to the 0. 5 cubed, just say, Professor, please. It's 125. 32 raised to the 1/5 may slow you down. Does anyone think they know what 32 raised to, not times, raised to the 1/5 might be? That's a strange one. Anyone have an idea? I'll put the answer out here. 32 raised to the 1/5, yes. 2. Now tell the class why, what did you do here to translate that into 2?
So 30 is like, you know, 2 is multiplied, it's multiplied to 5 times.
Okay, I'll see, are you telling, I think you've seen this. Are you telling me that that can translate into this 5th root of 32 raised to the 1st? That's what 32 raised to the 1/5 means. The bottom number tells you my denominator, tells you what root to take. And then of course the top number is the power. And sure enough, as he described, this 5th root of 32 is nice and even, it's 2. 64 raised to the 2/3, guys, it means this. Cube root, that's the bottom, 64 squared. Or, to make it a little easier, what could you do? That's what it means at this point. Can someone tell me another way that I might express this? To make it a little bit easier on me? Is there a cube root of 64 to begin with? And then could I do it like that? Will that give me the same answer? Which would be much easier. Mr. Park, guy, square 64 and then take the cube root of it. 64 squared, then cube root of that.
16. Yeah, 16.
How much?
16.
16.
Yeah.
If I did like this, I know the cube root of 64, if I did that separately, cube root of 64 is what, 4? 4 times 4 times 4. Mean squared, well, I end up the same answer. 16. Okay, just a translation. 16 raised to a negative 1/2, guys, be careful. A negative exponent says to a reciprocal, so this really is like 1 over square root 16. 16 raised to 1/2 is like a square root, it's 1 over. So if I calculate this, that's 1 over for a value, 1 over 4. Yes or no? And the last one, 8 raised to a negative 4/3. I would first do a reciprocal because of the negative sign. That says translate as 1/8 raised to the 4/3. Then translate further, I see the 3 indicates there's a cube root. Guys, we'll write mine like this, of 1/8 raised to an exponent of 4. I hope there's a nice answer for a cube root of 1/8. What is the cube root of 1/8? What's that, 1/2? And then 1/2 raised to the, on the outside there, 4, that's 1 over 16, and that's the value. Now, you say, Professor, that's just some basic math from way back, math grade 7 or grade 6, my teacher did this for us. Why did you write this down? Because now I'm going to introduce with these illustrations here, this word. And then we'll get out of your way here. You guys in the back there can see me. Logarithm. Abbreviated L-O-G. So we're into logarithms, L-O-G. Now, I want you to think of, I'm not going to give you the precise definition right now. At this point, I want you to associate with logarithm, or log, this word. We just did exponentials before the break. So let's bring exponents back. So guys, right now, just for an association, if I hear the word logarithm, in my mind, I'm thinking about exponent. That means let's go back to my examples here and watch what's going to happen. moving into the last part of chapter 4 here. My first example is 2 raised to the 0 is equal to 1. You say, Professor, the exponent's 0. So you tell me that that's what the log is. I'm saying here, you want to rewrite it. Look at this guy. With the abbreviated LOG logarithm. And you're going to say, well, Professor, you said associate the exponent is 0. That's all we're going to associate that word logarithm with is the exponent. The exponent is 0. Now you got to tell me a little bit more. What base was being used here in my first one is base 2. So that's written as a subscript and a 1 for my number. So 2 raised to the 0 is equal to 1. It's the same as saying this, except now it's in log form. Next one, let's rewrite this in log form here. 5 cubed is equal to 125. The log, which is associated with exponent, the log is 3. That's my exponent. No, so let's put a little space there. When does that happen? When the base is 5 and my number is 125. Those two are saying the same thing. Down here, 32 raised to the 1/5, we said it was 2, but how's this one? In the log form, logarithmic form, the log, the exponent, was 1/5. When was that happening? The base, of all things, was 32, and my number was 2. It's running from one to the other. The next one, 64 raised to the 2/3 equals 16. Yes, we got that out here. In log form, that means log is equal to, or the exponent's equal to, 2/3. And again, when is that happening? On this particular example, the base was 64. And it looks like my number was, where was I? It was 64. 2/3. Guys, what did I have here that I messed up, or did I mess up?
16.
Was it 16? Oh, I left out here, 16. Those two statements are saying the same thing. Next one, 16 raised to the negative 1/2 equals 1/4. Log form, log or exponent, in this case was negative 1/2. And again, you ask yourself, when was that happening? When the base was 16, and I think the number was 1/4. Last one, 8 raised to a negative 4/3 is equal to 1/8. Log form, the log or the exponent was negative 4/3. And when's that happening? When my base was 8. And I think my number to work with, guys, did I erase it here? Someone help me out. It was 1/4? Help me out. Or 1/16? Which one was it? 1/16? 1/16. That's where that would go. So I'm rewriting something from grade 7, grade 8. Now, a little bit more sophisticated, using this word log, or logarithm. Merely associated with an exponent. Okay? And you put the base in there and so forth and so on. That's the way it's expressed. Now, Michael, tell me, since you're close by, did I give the definition for log base A x on that handout somewhere? A definition.
So the domain of y equals log base ax.
Okay, log base A x equals y, right? Did I have that written? Somewhere on the handout, guys? Is that written anywhere on one of those handouts? Did I tell you what it means? They have on the side what this means. And based on what you saw here, what do you think it means? You see log base A x equals y. Did I have on the handout by definition, what does that mean?
X equals a to the y.
X is equal to a raised to the y. You drop the word log, you tell me what it means, by definition, it means that. Which is much like what we're doing over here. We take a close look here to get a connection here, guys. Michael, since you're close by, were there some restrictions on parts of this?
A is greater than 0.
Thank you, hang on now. So this subscript here is gonna be greater than 0. Can it be 1?
Cannot be 1.
Cannot be 1. Okay, that's a restriction. Any other restrictions?
The domain of y equals log base ax.
Oh, the x must be what then?
X is greater than 0.
Greater than 0. So few restrictions there. And that's what a logarithm will look like. Now, let me give you an example. With what Michael has given me, that's your definition in your textbook for a logarithm. If I give you this, log base 2, guys want to do this, maybe 128 is equal to 7. Have I satisfied that definition? I use for my base 2, he says, Professor, for A, which is your base, it's got to be greater than 0. I'm 2 is greater than 0. That's not 1. So this satisfies that restriction. And he says this 128, Professor, must be greater than 0. So have I satisfied the restrictions? Now, does anyone know why I'm saying log of 128 for an answer? I met the restrictions. Why is log of 128 base 2 7? Can anyone tell me to verify? Why is that statement true? Don't tell me what it means. What does that mean? Thank you. Isabel, is that you? Yeah. 2 raised to the 7th is equal to 128. It's exactly what it means from this discussion over here. If you raise 2 to the 7th power, you'll get 128. That's what it means. Okay, with all that said, guys, let's see if I'm ready for it. Oh boy, I think I am. There's your definition. I think I hit it here. Michael, let me do this before I jump into. Michael, help the class out. Are we in 4.2, 4.3? Where are we?
4.4.
Beautiful. 4.4. The definition is given to you guys based on what you see on the board here. Now, do I have a few there for you guys to answer? Like the number 1 says log of 1 base 2. Log of 49 base 7. Is that true? Let's put the answers in right quickly without me showing everything on the board. Guys, what is the first one? Log of 1 base 2. What's the answer? 0. 2 raised to the 0 is equal to 1. That's all they're asking. Next one, log of 49 base 7. 2. 7 squared equals 49. That's what it means, translate. Log of 1 9 base 3. That may slow you down a little bit. Log of 1 9 base 3.
-3.
Not negative 3. Negative 2. 3 raised to a negative 2 is 1 9. 1/3 times 1/3. The next one says log of, and I'll be careful on this next one, log of 27 base 1/3. Now guys, as they get a little harder, that's the one I just looked at, means this, 1/3 raised to what will give me 27. That's what it means. Now, can I, without just standing there and looking at it, trying to come up with numbers to make it work, is there a little scheme here, a little way I could do something here to maybe find the answer? Or maybe someone knows the answer right now. What's 1/3 raised to what will give you 27? Yes?
-3.
He says -3. Now, suppose you're not as quick. You say, wait, how do you get -3? You could do this as these things get harder. I'm going to rewrite each side in terms of a common base. Base 3 in this case. 1/3 could be expressed, if you wish, like that. That's 1/3. On the outside is x. 27, same base, could be expressed as 3 cubed. And then, all I'm saying is, if I have the same base 3 on each side, my goodness, guys, common sense tells me the left-hand side, which is negative x, is equal to, for the exponent on the right-hand side, 3. And if I solve this for x, I get the answer that he gave me fairly quickly. X is equal to a -3. And that's your log value there. So if they get a little bit tougher, please write it out. Do what you can with the bases. The next one is a little bit tougher. A log, let's see, base 32 of 8. Now this one may require a little bit of work. I would suggest, this is me, it's up to you, I'd say, Professor, this is unknown. Is that true? I don't know what it is. And then translated, it means 32 raised to something is supposed to give me 8. So guys, make sure I have this, I think I have it down correctly. Now, what would you suggest at this point? Without just sitting there trying to guess what x must be. I would try to rewrite each side in terms of a common base. What would be a nice number to use as a common base for these two? 2. Rewrite 32 as 2 raised to the 5th. That's 32, that's not 10. And 8 as 2 cubed. And therefore, since I have the 2's to match up, the exponents must match up. It makes those two sides equal. So 5x is equal to 3. Here's your answer. If I have no mistake in all the arithmetic here, 3/5. So log of 8 base 32 is 3/5. Is that making sense, guys? Connected. Now, I think, was there another one remaining here to do? I think there was. Oh, there is. Now, I have not yet. I will eventually. All of a sudden, I use this notation, ln square root e. Not log. Is it fresh? If you make a mistake, you type this up wrong or something when you create this worksheet, you put ln and not log. Guys, when they use ln, still abbreviation for logarithm, the word logarithm, but they use ln, this is for the special logarithm, where they use the base to be e. In other words, ln x is equivalent to log base e of x. So what's understood to be here? Understood to be an e. You're never gonna see it written. If you see ln, they call it a natural log. That natural log has for a base e, understood if you see the ln notation. So if you don't find the answer to this, it says translated, that base, now I'm squeezing in here, it's not gonna be written for you, means e raised to what will give me square root e. And that has to be 1/2. Has to be 1/2. And therefore your answer up there is 1/2. Okay, just some basic information about logs. And then an ln with a special log, base e. Okay? Now I'm looking at where I'm going here, try to get a lot of this done. The next part on the handout, Michael, does it say find the domain? Okay, guys, here we go. Find the domain of these log functions. By the way, I have not sketched one of these yet. Before the break, did I sketch an exponential for you? Did we spend some time sketching exponentials? But I have not sketched a log yet. Okay, we'll take a look at that before the break. But first, let me erase all this. If I follow the handout, Michael, read that to me as I copy it down. It says, find the domain, name the function for me, and students can follow me. What was the first function?
F of x equals ln parentheses x minus 3.
X minus 3. They do not want you to do anything to it. Just look at it and tell me based on, I hope I didn't erase it. Oh, let's see if I did. Oh, I didn't. This right here, guys, look at this. That's your domain, by definition. That's always gonna be positive. So if you want to find the domain for a logarithm, and this is a special logarithm, ln, which understood to be a base e, this must be greater than 0 by definition, right there. And therefore, if you set that greater than 0 and solve, guys, you're going to end up with x is greater than 3. If you want this in interval notation, you have that, and there's your domain. Done. Michael, go to the next one.
G of x equals log x squared base 2.
Log base 2, hang on now, x squared. They're asking for the domain. Okay, guys, keep in mind, this must be greater than 0. x squared. So what can I replace x by? Can I replace x by any number I wish? Because as you square it becomes positive, which looks like it would satisfy this in the definition for the domain, but there's one catch. Who sees the one catch? As I look at it, guys, I could replace x by -2 here.
It's always positive.
Here again, I heard something.
Always positive minus
Oh, but what? There's one number you can't use.
0.
Zero. You can't let x be zero. 0 squared is 0, and this says by definition, though, you want that to come out to be greater than 0, not equal to. It didn't say greater than or equal to. But here I cannot let x be 0. This is my domain. I want this in integral notation, negative infinity up to 0, union 0 to infinity. There's your domain. Done. Michael, how about a discussion on number 3?
Hx equals log base 3,
Okay, we're gonna have log base 3,
x over x plus 1.
beautiful. X over x plus 1. Again, guys, restriction, they won't just, restriction on the domain, the x's, the x's, the x's, I see by definition over there. This is gotta be greater than 0. About the domain. Now remind me, what did we do way back, probably the first day I met you guys? How does one solve this? X over x plus 1 is gotta be greater than 0. You gotta solve for x. Anyone remember way back the first day I think I met you? We did something like this. Anyone remind me? Go for it.
Multiply both sides by x plus 1.
Go again.
Multiply both sides by x.
Nope, I knew you were gonna do that.
X can be -1.
Beautiful, x cannot be a -1, I agree 100%. X cannot be equal to a -1, for sure. Now, something else though, besides that. Who the cause? Now, you guys have done that in this class over and over and over, and sometimes on quizzes or exams, I'll even write out, try this, do it this way. What am I talking about? Oops, I heard
Sign analysis.
sign analysis. Sign analysis. Look at this, guys. This, I'm going to go to a number line, and I'm going to place my so-called critical numbers. Now, -1 definitely is one of my critical numbers. Can't use it. There's another critical number. What is it? If I pick up all the critical numbers, then we'll start testing through sign analysis to make sure we get the answer here. What's my other critical number? 0. You look at the numerator, it says that equals 0, it said x equals 0, you got 0. Can't use it, but those are my two critical numbers, and then you gotta be very patient, and we've done this so many times, test in on those intervals. Guys, to the left, I'm gonna try -2 myself, it's up to you. In between, I'm gonna try -1/2. Out to the right, I'm gonna try 4. Now place those numbers quickly, so let's hopefully work. Okay, -2, replacing x by -2 here, guys, we'll get a negative, of course, on top, and a negative on the bottom, which turns out to be a positive, and that's what I want. Is that true? Through sign analysis, replacing x by -2. So this works for my domain. In between, I doubt it, but we'll try it, -1/2. Replace x by -1/2, of course it's negative in my numerator. And -1/2 plus 1 is a positive 1/2. That's a negative over a positive, so it'll be a negative, I can't use it. 4, replace x by 4 in my numerator, that's a positive. Denominator, 4 plus 1 is 5, another positive. That definitely will work. Gives me a positive, and there's my domain. So when my student said x cannot be a -1, sure enough, x cannot be a -1, but there's more. Okay, my domain, guys, let's write this out. Domain in integral notation, negative infinity, up to, looks like a -1, union, it looks like it jumps to 0 through infinity. Wow, that's my domain. Is that making sense at this point? Michael, how many more of those domains are there? One more, what's my last one?
K of X.
Okay, hang on just one second. K of X, that's what 4 X. Okay, K of X is equal to what?
ln
Ln, natural log, base E, okay.
16 minus x squared.
Beautiful. Then we're gonna what can I replace X by? And all depends on that restriction. Which tells me in this case, what, 16 minus X squared must be greater than 0. Or this will not be valid. Guys, that will factor, if that factor would help you. And in the order you see it, it looks like that. Now tell me, how would you solve that inequality of the first night I met you to find the solution?
This is like
The sign analysis again? Should I use sign analysis again? Yeah, so to solve this, my critical numbers are in green here. Guys, I see 4 and -4, no problem. And they are not to be included. And if I'm patient on this last problem for the domain, let's go through the check. Guys, to the left, I'm gonna try maybe a -6. In between, we'll try 0. Out to the right, we'll try 10. Which choices are, of course, up to you. -6, be very careful, replacing X by -6 becomes 4, subtract the -6. That's gonna turn into a positive 10. 4 plus a -6 gives me a -2. And that is not what I want. In between, I'm trying 0. 4 subtract 0, of course, is a +4. 4 plus 0 is +4. That will work. Gives me a positive. To the right, I'm trying 10. 4 subtract 10, of course, is a -6. 4 plus 10 is 14, positive, will not work. So therefore, my domain, by sign analysis, is -4 up to 4. If I follow the definition, which I did, I hope. So far, so good? You guys are about to wind down here. So far, so good, on logarithms. Okay, now, whew, let's see if I'm ready. I am ready. This may not be on your handout, but I gotta do it now. Guys, when we move back over here on the side, perhaps it's a little bit better here. Let me ask you as class, did this from maybe a simple math class changed into a log make a connection for you? Does that help to show something from way back in a math class, and all of a sudden we rewrite it with the word log, and actually be saying the same thing? Okay, so that's a translation of what log means. Now though, what I need to do, I'm gonna watch my time here. We did a lot of work tonight. I'd like to, on the side here, do this. I'm gonna take f of x is equal to 2 raised to the x. Seems like I've been using that a lot tonight. 2 raised to the x. Now I'd like to find, here we go guys, its inverse. Let's make a connection here. Let's make a connection. First, can I verify? Can you help me to verify? Is this function to begin with a one-to-one function? It's not one-to-one. It has no inverse. Can I say it is one-to-one? It's a one-to-one function. And I think you saw what 2 raised to the x looks like before, that's the horizontal line test, so it is 1 to 1. So it has the inverse. The 2 steps. Find that inverse. Step 1, interchange the variables. Only 2 steps here. Step 2, now since we've had a little discussion, I'd like to solve for y. Can anyone tell me another way to express x equal to 2 raised to the y with the discussion we just had, and maybe bring a log in? Anyone tell me another way to say x equals 2 raised to the y? Can be expressed as professor with log now, based on what we've done with logs. How can I rewrite this with log? I want this word. I'll help you out this much. I know the basis will be a 2.
X equals 1.
And x is equal to what? There's the inverse. This and this are saying the same thing, based on what we've done in class. These 2 statements are saying identical, same thing. Guys, so 2 raised to the y is equal to x. This is my inverse, and we can make it a stronger statement. There's the inverse of 2 raised to the x. Now, that said, I gotta be careful. I'm gonna take this and this. And sort of close down tonight with this. Now let's graph both those functions on the same grid and see what's happening, and does it connect with something we should know in closing down this for right now. Guys, so on the grid here, let's try this. Here we go. Guys, 2 raised to the x, we just quickly sketch it. I'm trying to use a different color. And then I'll sketch its inverse, which is a log. Guys, let's try 2 raised to the x. This very much should work. Okay, 2 raised to the x. You saw it earlier. It looks something like this. That's what we did tonight. Now I'd like to graph in a different color, maybe choose this orange. I'd like to graph its inverse, which is this. Now, can someone help me out in closing down to make a beautiful connection to all this math? There's the 2 raised to the x that we did way back tonight. Now I'd like to graph this. And then that will be representing the inverse of the gradient. Does anyone have an idea how I can graph log of x base 2 is equal to y?
Reflect across y equals x.
Tell me again.
Reflect across y equals x.
Oh, beautiful. Oh, you got ahead of me. Beautiful, beautiful. I love that. Brianna says, Professor, why don't you go ahead and sketch y is equal to x? That reflecting line that we talked about. And if you want to get this done fairly quickly, oh, she's got it. I just want to wait till the end to do that. She says, Professor, do this. Sketch the best you can of here. Y is equal to x. Make it look like this. So guys, that's y is equal to x. One from the origin, and we'll label it. Now, Brianna, tell the class, in case somebody may not be able to see what you mean, you will take my green graph and reflect it over, not the x-axis, not the y-axis, through this line y is equal to x. Brianna, describe for me, I should have you come up and do it for us. Just give me a description, and I'll do it. What are you telling me the graph looks like?
We just flip it over.
Okay, we'll flip it over. Now, when I flip it over, are you telling me it might look like this? Yes or no? as you think the reflection across that slanted line, y is equal to x, may look like that if I take the green and flip it over that slanted line there. And let this represent y is equal to, yes, we have what, log base 2 x. Now, to close this down, watch my time here. Locked tonight, locked. Let's go back to that green graph. Someone help me out here. Can someone look at the green graph and tell me what is its domain? If you just based on the graph, what's its domain? From left to right. Is it open? Is it everything? From left to right. How about the range on the green? How far down does it drop? For the y value. Looks like it's dropping down towards what, the x-axis, which is what, 0? So the range is 0 and it rises forever. Is that true? Now that's green. Now if I look at its inverse, the blue. Now look at the graph of the blue from left to right for the domain along the x-axis. And you got to keep in mind, the 0 here. How would you describe the domain from left to right for the blue? Go for it.
0,
Beautiful. Everything to the right of 0.
You'll need to unlock your iPhone first.
How about the range on the blue? The up and down. On the blue. Negative infinity. It looks like it's rising forever. No boundary like a 4 earlier. Negative infinity through positive infinity. No bounds to worry about here. Guys, please tell me. Did these two switch? As they should for an inverse. The domain becomes a range, the range becomes a domain, and that's what should happen for an inverse. Now, in closing down, I need to talk to you a little bit here. Can anyone remind me, how does one check, after you find the inverse, how does one check it? Well, you're about to check this one on the quiz Wednesday. So after you find the inverse, how does one check to see if you have the inverse? I'm gonna form a composite. I'm gonna form mine in this direction of your function with its inverse, and you had better get x. Now watch what happens in closing down and make you think a little bit here. Guys, this composite means f of the inverse. That's the left-hand side. We finish that left-hand side up. The inverse, we think, find where it is, we think, oh, here it is, log base 2 of x, we think that's the inverse. That's that. I got f around that. Now watch what's going to happen. Now what does that mean to finish up? Take log base 2 of x into your f function, in other words, take it back here. And replace x by that. It's going to look awkward. It's going to be 2 raised to this. If I did my replacement correctly. What's that supposed to be equal to? If we truly have the correct inverse here, what should the answer for 2 raised to log base 2 x be equivalent to? If I'm correct. Look how strange that looks. It's got to be equal to x. If I accept the inverse and the composite here that I have on the board, it's got to be. Now I'm going to throw a few numbers at you and let you just think about this before I see you on Wednesday. Guys, I'm going to throw a 4 in there right quickly. If I throw a 4 in there for x, what's the log of 4 base 2? In other words, 2 raised to what is 4? 2. And then what's 2 raised to the 2? 4. Is that the original x I gave you? Let me try 16. If I replace x by 16 here and here. First here. What's the log of 16 base 2? 2 raised to what will give you 16? 4. 2 raised to the 4th? 16. Does that give you the original 16 I gave you, the X. So is that statement true for all the X replacements? There's some restrictions there. For the X replacements, looks like it's working. That's the inverse. So the inverse of an exponential that we started class out with tonight turns out to be, for the end of class tonight, the inverse is a logarithm. And that's the connection between the two. Wow, 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 wow. Woo! Any questions? Chapter 4 is almost, not quite, almost finished. I'm hoping to start trig on Wednesday, give you a brief introduction. I got a little bit more to say about chapter 4, brief introduction on that, and I got a quiz. Now, here's what I need to talk about, the quiz. I'm not doing logs on the quiz. I'm doing, I think the two topics were what, guys, remind me? Find the composite, and then find the inverse. Now, I'm not gonna have logs on there. Just some basic problems for you to do, functions to find, composite and inverse. Now, I don't have the time, I'll be here at 4 o'clock though, but, for an example, you can try this. I may give you a function like that and ask you to find its inverse. And I'll guarantee it's a one-to-one function first, but it's a one-to-one function. Now I'll ask you to please go through and be patient, and don't mess this up. Watch me go ahead and do all those here. I'm not going to do all those here. Find the inverse. How do we find the inverse? I'm going to interchange. Makes this look like this. Interchange the X and the Y. That's step 1. Step 2 is solve for Y. I would suggest you cross multiply or multiply through by a common denominator. I'm going to do mine fairly quickly. I think y'all know how to do this. And I have now, at this point, bang, I'm going real quickly. To solve for Y, I need to get the Y terms together, so I'm going to move that over. And X, Y, subtract 2Y, the Y terms are together. Move that 5X over to the other side, out of the way. And have a negative 5X subtract 4. And why get those Y's together? We'll take out a common factor of what? Y, and have X minus 2. Now look at this. This is a beautiful example for a quiz. Divide through by X minus 2. X minus 2, these cancel. Guys, if there's no mistake, I'm stepping back and looking at it, I think we're good. This is your inverse. That true? Now, one more ask you after you find the inverse, please tell me its domain and range. Guys, the domain on this answer I just found here in the orange is X cannot be what? 2. That's easily done. If I ask you for the range on the orange, the Y values, the range, that might be a little bit more difficult the way the orange looks. But some students may visualize a graph and may be able to tell me. What I would suggest for the harder part, yes, I would say for the range of the inverse, professor, why don't you go back and find the domain of the original? Are they supposed to be the same? And what was the domain on the original here, the blue? X cannot be a negative 5. This is the domain on the original function. X cannot be a negative 5. Now let's go to the orange. That must be the range on this one. Y cannot be negative 5. That's true? Make a connection like that? And then, Aaron, to make it a nice quiz, got all this going on here. You're going to show me, I don't have the time tonight to show you. You're going to show now also this. You got to show me that when you form the composite, geez, all these markers are out. You got to form the composite, the function with the inverse of X, and you better show me it comes up to be X. That's a check. We got domain, range, a check. I doubt if I ask you to graph. Now, if you were to graph this one, guys, this is a rational function. Anyone tell me the way this, back here, here's the original function. Is this a rational function? You guys had a rational function on that last exam. Anyone write quickly, I'm not gonna graph it though. Anyone write quickly and tell me, where is the x-intercept on the blue functions graph? X-intercept. Two. Two. What should that be when I go to the inverse? The y-intercept. So if I go to the y-intercept, which, the inverse, I find the y-intercept, we think the inverse is here. And how do I find the y-intercept? Replace x by 0, this drops out, that drops out, by -4 over -2, is that 2? Now, right quickly, anyone tell me without graphing, where is my vertical asymptote located on the original function in the blue? Vertical asymptote. -5. What should that correspond with on the inverse? The horizontal asymptote. If you take a close look at this right here, guys, and you know how to find a horizontal asymptote, it is -5. They agree. They're interchangeable. Wow, what a class. Mr. Park,
Mhm.
Anna, you guys have anything to say?
No.
Nothing?
Yeah.
Okay. Guys, I thought it was a good class, had a lot of information. I'm wiped out, I'm sure you're wiped out too. There's a lot of information here. Please get ready for that quiz, I'll be here at 4 o'clock.